All right, let's jump right in. We're about to explore something that feels like it's been ripped straight out of a sci-fi novel. But believe it or not, it's actually happening in labs right now. We're talking about a totally new kind of mind, a living computer. I want you to just picture this for a second. A bunch of living neurons just firing away, wiring themselves together inside a little petri dish. It's basically a tiny brain, grown completely from scratch. But here's the twist. This brain, it's not being grown for a person. No, it's being designed to be the CPU, the actual living hardware for a brand new kind of machine. So, is this all just some wild futuristic fantasy? Or are we, right now, standing on the edge of a whole new era of computing? Well, that's exactly what we're here to figure out. You know, the idea of a biological computer, it's not as new as you might think. Actually, our own stories, our science fiction, have been wrestling with this very concept for decades, long before the science ever caught up. And it's really cool to see how fiction has played with this. You've got two totally different takes here. On one hand, in the novel Wildcard, you have these big brains that are basically genetically engineered from scratch to do a specific job. But then you have the 1980 film Saturn III, where the idea is, well, it's a lot creepier. A robot's mind is literally powered by repurposed human brain tissue. And yeah, that leads to some pretty unpredictable results. Okay, so this is where the story takes a turn. This is where fiction stops and reality begins. What used to be just a wild plot device is now a real thing that scientists are studying in labs today. So the official name is brain organoids, but honestly, mini brains pretty much hits the nail on the head. We're not talking about full-sized brains here. Think of them as these tiny, three-dimensional clusters of brain cells grown from stem cells that actually start to look and act a lot like a tiny, developing human brain. So how in the world do they even make these things? Well, the process is just fascinating. Basically, they start by taking some stem cells, then they put these cells into the special, like a nutrient soup that gets them to grow. And here's the part that just blows my mind. They don't need a blueprint. The cells just do it themselves. They self-organize and naturally start forming those complex, layered structures you'd see in a real brain. It's incredible. Okay, so you're probably wondering, why go through all this trouble? What's the point? Well, the potential here is it's absolutely revolutionary. See, unlike a rigid silicon chip with its fixed pathways, these things can physically change and adapt as they learn. They are incredibly good at recognizing complex patterns, the same way you can instantly spot a friend's face in a huge crowd. And maybe, just maybe, they operate on completely different physical principles than our current computers, which could unlock a whole new world of computation. And that last part, that idea that they might work on totally different principles, that's where things get really, really weird. I mean, truly mind-bending. Because it forces us to ask one of the biggest questions there is about the puzzle that connects the physical brain to the intangible mind. Think about it. If you can build the hardware of a brain, does the software, I'm talking about consciousness itself, does it just pop into existence? Or is there something else going on? Something we're missing entirely? This is where a really brilliant thinker, the mathematical physicist Sir Roger Penrose, comes in. For years, he's been arguing that consciousness isn't something you can just calculate, like a big math problem. He's convinced it's a completely different kind of phenomenon altogether. Now, his theory, it's called Orch-OR, or I'll be honest, it is out there. It suggests that consciousness doesn't come from the simple on-off signals between neurons, the kind of thing a computer could copy. No, he thinks it comes from quantum computations happening on a tiny scale inside these little protein structures in our neurons called microtubules. So it's not just an algorithm. He's suggesting it's a real physical event tied to the very fabric of the universe, and that's what creates our experience of, well, being. And this is what's so cool about where we are right now. We're basically at a crossroads. And our modern tech is putting his theory to the test from two sides, right? If we manage to build a truly conscious AGI using regular old silicon computers, well, that would be a huge problem for Penrose's theory. But on the flip side, these new organic computers, they could be the exact tool we need to finally prove him right by letting us actually look for those quantum effects in a real living biological system. And that brings us from the how to the should we. Let's just say we succeed. Let's say we actually create a thinking, feeling, organic machine. What happens then? Suddenly, we're not in a science lab anymore. We're in an ethical maze, and there are no easy answers. all of a sudden the questions get really heavy and really urgent. If that little blob of cells in a dish develops even the tiniest spark of awareness, does it have rights? Is it okay to just turn it on and off, to use it for whatever we want? I mean, what is it? Is it just a super advanced piece of lab equipment, a tool we built to solve problems? Or is it a being? Something that deserves respect, maybe even protection? That line gets so blurry, and frankly, it's terrifying. And this, right here, brings us full circle, back to that warning from the movie Saturn 3. I mean, if we build a mind that can learn and adapt, a mind that could one day think on a level we can't even comprehend, what on earth makes us think we can control it? So, look at the journey we've just been on. We went from science fiction to the absolute cutting edge of science and landed right in the middle of the deepest questions of philosophy and ethics. It's a path that's leading us somewhere. Well, somewhere very uncertain and very blurry. If there's one big thing to take away from all of this, it's that the lines we've always drawn in the sound, between what's alive and what's a machine, between a thought and a calculation, even between a creator and their creation, all of those lines are starting to disappear right in front of us. And I want to leave you with one last question to chew on. As we start down this incredible, and let's be honest, maybe dangerous path to build grand new kinds of minds, maybe the biggest discoveries won't be about them at all. Maybe the real question is, what is this whole journey going to teach us about our own minds and what it really truly means to be human?